Hello everyone. In today's video, we will be diving deep into a comprehensive comparison of two powerful programming languages, MATLAB and Python. These two programming languages are widely used in various fields. Each has its own merits and demerits. By the end of this video, you will have a clear understanding of which language might be the best fit for your specific needs. So let's get started. To kick things off, let's begin our discussion with the history of these two languages. MATLAB is a short form of Matrix Laboratory. It's a proprietary numerical computing environment primarily designed for engineering, scientific, and mathematical tasks. It is known for its powerful built-in functions and toolboxes, which simplify complex and numerical and mathematical operations. On the flip side, Python is a versatile, open-source, and high-level programming language known for its readability and easy syntax. Python's applications span a wide range of fields, from web development to data science, making it a popular choice among developers worldwide. If we talk about the cost and license, then unfortunately MATLAB is not free and often comes with a substantial price tag, making it less accessible for individuals and small projects. Licensing fees can be a significant consideration for the newcomers. In contrast, Python is an open source and completely free to use. This cost advantage has contributed to Python's widespread adoption and community growth. Learning a new language is always a concern. MATLAB, with its focus on mathematical operations, can have a steeper learning curve for those new to programming. However, if you have a strong background in mathematics, MATLAB syntax may feel more intuitive. Python, with its beginner-friendly syntax and extensive documentation, is often considered easier or probably the easiest language to learn, making it an excellent choice for newcomers to programming. The size and engagement of the user community can greatly impact our experience with a programming language. MATLAB has a dedicated community, but it's smaller compared to Python's vast and active user base. Python's community is known for its responsiveness and willingness to help, with numerous online forums and resources available for troubleshooting and learning like Stack Overflow. Let's delve into the programming paradigm now. MATLAB primarily emphasizes a matrix-based approach, making it ideal for linear algebra and numerical computing. This strength makes it a top choice for fields such as signal processing and control systems. Python, on the other hand, offers versatility, supporting various programming paradigms, including procedural, object-oriented, and functional programming. This flexibility lends itself well into a broad range of applications. Both languages have a rich ecosystem of libraries and toolboxes. MATLAB boasts an extensive collection of specialized toolboxes which can significantly expedite work in specific domains. Python's strength lies in its vast library selection, including NumPy, SciPy, and so on. NumPy is mainly used for numerical computing, whereas SciPy is popular for scientific tasks. Matplotlib is for data visualization, and scikit-learn for machine learning, and so on. When it comes to data visualization, MATLAB offers powerful plotting capabilities out of the box. its ability to generate publication quality plots with ease is highly regarded. Python, on the other hand, leverages libraries like MATLAB and Seaborn, providing comprehensive data visualization tools and the flexibility to customize the plots as per one's need. Machine learning and data science have gained immense popularity, and both languages are relevant in this domain. MATLAB offers machine learning toolbox, simplifying the implementation of various algorithms. Python, however, dominates the field of data science, with libraries such as scikit-learn for machine learning, TensorFlow for deep learning, and Pandas for data manipulation, offering a robust toolkit for data scientists. Integration with other technologies and systems is a crucial consideration. MATLAB's capabilities for interfacing with these languages and systems make it suitable for integrating into existing workflows. Python's versatility shines into integration thanks to its extensive libraries and compatibility with numerous programming languages and technologies. Performance and speed can be vital depending on your tasks. MATLAB's highly optimized numerical application functions often excel in terms of speed when handling mathematical operations. Python's with libraries like NumPy and optional usage of Cython can achieve significant operation improvements, though it may require more optimization efforts. Both MATLAB and Python find their niches in various industries. MATLAB is commonly used in fields like engineering, physics, and control systems, where specialized mathematical functions are crucial. Python, with its wide applicability, has made its mark in web development, data analysis, machine learning, artificial intelligence, networking, statistics, and more. Its versatility makes it a strong contender in a tech world. So finally, as we conclude this comparison, it is essential to remember that the choice between MATLAB and Python ultimately depends on your specific needs, your familiarity with the language, and the resources available. For more complex computations and specialization domains, MATLAB remains a top choice. In contrast, Python's versatile and cost-effectiveness and expansive library ecosystem can make it a go-to language for many. So, which one should you use? It's all about understanding your requirements and considering the factors that we have discussed above. Regardless of your choice, both languages are powerful tools for solving a wide range of problems. Thank you for joining today. If you found this video helpful, please give it a thumb up and subscribe to our channel for more informative content. And don't forget to hit the notification bell. If you have any questions or thoughts on MATLAB or Python, feel free to share them in the comment section below. We look forward to seeing you in the next video. Until then, happy coding!